Okay, hello everyone. So Friday, today we'll continue with our journey to solve all the problems from LeetCode.io. So here we can see our roadmap. So we finished pretty much all problems on arrays and hashing. We finished the two-pointer problems last stream. And today we'll be working on this couple of problems on stack. So we'll have the min stack. I think we started last stream, the min stack part, and today we'll be continuing with this one. Then I have a couple of other announcements. So I'll try to do like 2 streams a week. One stream will be LeetCode solving problems, and the second would be like a live learning session which I intend now. I think I did one with loco.rs, which was a pretty good experience overall. I had like mixed feelings about the framework. So I want, but the interesting fact was that has a lot of views. So looks like people are interested in this kind of content. So probably I'll be switching from LeetCode to towards more like live learning and this kind of experience of building apps, not only algorithms and data structures. Maybe though I would change the structure a bit and start creating videos daily with the problems where I can solve all the problems on LeetCode in rustlang, past here are my solutions and so on. But we'll see. We'll see how I'll manage with the time, how I'll manage with the other resources. Um, in pipeline, though, I do have an app, a desktop app. So I plan to build it using Tori. So it's a cross-platform tool to build desktop application in rustlang. So for front end, I'll be using Vue.js or React. I didn't decide yet. So probably I'll do a poll on this channel and see what would be people interested in. But I'm not sure if I have enough people subscribed to even do the voting. But we'll see. I'll try to make a vote, a poll, and see what people are more interested in, React or Vue.js. So for the backend, for sure, it will be like Tori. So the app would be like a Monte Carlo simulation. So for statistics, because I'm interested also in finance and like value investing. So that would be a cool application, I think, to have to do different kind of Monte Carlo simulations and see the results. Okay, so yeah, I think it's a bit too long of an intro. Though the people who watch my streams, maybe they're interested in what I'm thinking about XYZ topic. On what are my plans. I guess that would be a useful information for them. Okay, so yeah, let's check this one. So the min stack problem. We started the last stream. I think we did a bit of brainstorming, though I think I didn't handle properly the get min stuff because I didn't manage to make it in O1 in constant time. So my results I think was linear time for getting them in because where I think min it's fine. We managed to make it in constant time, but pop when we pop an element, that was the trouble for us because I think my popping solution is to find the minimum and update the minimum. So yeah, this approach unfortunately doesn't work, and also it was not working even here because it has some bugs. So I think I'll be moving this problem in my VS Code. So because I want to have a better feeling on what's going on there and how how to write the code. Yeah. Okay, so yeah, once again, let's read what they ask from us. So we need to implement a min stack. So it's a good design problem where we'll need to support like push, pop, top, which are like classic functions or classic interface for a min stack. And we'll need to retrieve the minimum elements in constant time. But not only minimum element, but all the other like push, pop, top, and get min. All of them should be in constant time. So that's the tricky part, because you'll need to have a key for this kind of problem. Okay, yeah. So my process of solving this kind of problems, usually what I do, I try to move all this code into some editor because I have like better integration. It'll be easier for me to handle all the things there. So yeah, probably I'll zoom it a bit. It's kind of too big. So yeah, first stage, let me create this problem in VS Code. So we'll do cargo new lib. So it's called min stack. Problem number 155. So yeah, let me move there, min stack, and I'll be opening a new VS Code terminal. So let me zoom in for you guys to see it better. Maybe it's too much. Yeah, I do not usually use the code like editor to be zoomed this big, because yeah, when I work, I do not need it to be zoomed, but this looks better, and people, if they're watching from their smartphones or any other devices, at least they can read the code and try to follow. So I also do have a glass of water to cleanse my throat. So yeah, let's copy first this stuff. So here, what do we have? We do have like a structure. It's called min stack. So this would be like the things needed to for us to provide. So I guess for now I'll just clean up everything, because we don't know what exactly we'll be writing. So here, yeah, I don't need this comment. I'll clean it up. So this is the interface provided by the problem. So what we'll need to do is write down the code to satisfy all these needs of ours. Okay, so yeah, what I do like to do often is to have like my unit tests ready. So for all those functions, we'll try to do some unit tests. So this will be pretty helpful. Okay, so yeah, we can try like a, I don't know, a test-driven approach. So a TDD style of programming. So usually you start by first adding a test. So we can create like a test, min stack, push, or new. Okay, so new will be okay. So we can create this kind of test. Yeah, I'll need to tell it that that's an fn. So this test would kind of mean that we have like a min stack. So yeah, in hindsight, we will do this test, for example, when we don't have anything at first. So we'll create the first definition that we have like a min stack. So what easier thing we can do, min stack, which will be like a min stack new, and here we will need to have our min stack. So I don't know that is defined. There is such thing in Rust. because I'm like a backend engineer and mainly working with TypeScript. But I guess this will not work. It will not compile, first of all, because we don't have it's undeclared at first. So first thing which we'll need to do, kind of to declare this min stack, and we'll need to have the first implementation to have the new part. Impl min stack, and let's add a new. So new in our case would be it needs to return the self, so we can do like min stack and nothing here. So this would be good enough for the first test to run. So that would be like a test-driven development approach. First, we define our new part. Next, we can add multiple tests. Like another test we can add would be like test min stack push. Okay, so yeah, we can add multiple tests, but let's add the push operator first. So here again, we'll be creating a min stack. Let mutable min stack. We'll do like min stack new. But we'll need to push something in our stack now. Push, so we'll push an item. Let's push 1. And here, I guess, in order to test push, probably we'll need to implement pop as well. So maybe a good idea would be to implement both of them at the same time, or we can leave it as it is for now, because this will fail as well. So it will tell that no method push found. Okay, so we can do like exists. Maybe that would be better for the time being. New exists. Okay, so this will be like definition. It depends on case to case. Sometimes I go such a granular manner, like to add all the unit tests for all these cases. Often I bypass things. Maybe I dive deeper right away more into like the meat of the data structure. But yeah, let's continue for now. So we run this test, it doesn't work. If we run all the tests, we do that using cargo test, but it tells that method push doesn't work. So here, I guess what we'll need to do is we'll need to add the definition of push. So yeah, we'll be mutating. So we'll need like a mutable self. Then we'll need a value. Yeah, usually when you implement a data structure, you don't want to bind specifically to like a primitive type. So a better approach would be to have like a generic type, so something like this here, and here we can actually we have like a min stack of t generic type, and we'll be passing here the t generic. So that would be like a better approach overall. But yeah, for the sake of this problem, I don't want to change my interface. So I'll be just creating my val, which will be an i32. So do we need to return anything back? We don't. So that would be the function. This would be kind of enough for this one to work. Now we can run both tests. And we'll have like push exists, new exists. That's fine, but I'm not sure if these tests do make any sense to keep them long term. Most of the time, that would be an iterative approach to write like test-driven development programming. But once you start like building up code, very likely you'll get rid of those tests because they do not bring much. They did not test much. Okay, so I guess let's keep it for now, but let's say once we start moving on, like for pop actually, for pop, would we will yeah, let's continue. For the time being, let's continue. So test min stack that pop exists. So we'll do the same. Probably even here I'll not do exist, but I'll do like an OK because I want to have some business logic already. So I have my test. I define my test here. Yeah, so probably we don't even need here to have, we just need to do a min stack new. And that would be all of our tests. And here to call the push function. So for the pop, I guess what we'll need to do is like first define our stack. So we'll do like min stack new. Then we'll need to push something. Yeah, let's push one, and then we'll do like min stack pop. So yeah, we don't have pop for now because we'll need to implement it, but now we'll be able to assert something. So what we can do an assertion like min stack, I guess len. Yeah, it's not necessarily, usually a stack doesn't have these features, but probably for testing purposes, I would allow to have a len function, or I don't know how to do it better. Okay, I guess let's keep it simple for now. We'll have pop. Yeah, it doesn't work as we don't have it defined yet, so we'll need to define what would be the logic for pop. We'll have a mutable self here, and that would be enough for our thing here to work. Yeah, let me run the tests. Yeah, all tests are fine. Yeah, these are not used pretty much anywhere. So this is why they are like dead code for now. Yeah, let's move on and add the other two, because here we have a little bit more interesting things. So here, for example, we have a top, so we'll need to see what's on the top of our stack. And we'll need to store the main part. Yeah, so let's add the test. You'll see by the end of like coding of this min stack, I'll get rid of these tests. But this would be like an instructive moment on how to write test-driven development code. So you go iteratively. You just write the minimum amount of code for the unit test to work. So we'll have like top, okay. So for top, what we'll need to do just something like this. So define our stack. And then we'll do like a min stack top. Unfortunately, we don't have any anything written in our stack, so so top is empty at this moment. But if we see the definition on how do they want us to write top, it's expected to be always something. So I guess by the problem's requirements, we shouldn't call top ever without like pushing something first. So let's push something first and then we'll do top. It doesn't work as, yeah, we'll need to define the top part. So we'll have like top, top will not mutate anything, so we'll have just a reference on self. So it needs to return an I32. And yeah, for now that's a little bit more interesting, because for top, this expected, we can have our first assertion, and this needs to be expected to 1. This interface, though, it's a bit ugly, because let's say a better way to do it would be like to return here an option on I32. This would be a better approach on how we can write it. But if I'll change now the interface, the unit test will not work. Okay, so we do have our first test, and we expect to return something in I32. But if you look at the code here, we need to return a thing which were pushed inside. So I guess now we'll need to start writing some code here. First thing which we can do, we can have like a data property in our struct, which will be a vec of I32s. And what we can do here, we can initialize our min stack with this. And for push, we'll be doing the yeah, we'll do like self data.push value. So that would be the pushing part. For popping, we will need to do like self.data.pop. Yeah, that would be, it's not kind of reflected in our unit test for now. But now at least we'll have the possibility to check what's in the top of our stack. So simplest way to do it will be like self.data.last, and here we will need to unwrap. Okay, yeah, and this kind of needs to be dereferenced. So that would be the logic for the topping. So this test works just fine. So let's check the other. Now we added some code to our data structure. So we'll do cargo tests, and very, very nice. Everything works just fine. So do we have here a pub? Yeah, we'll need to create them as public, because they will be public. So I don't feel like this would introduce new problems. And we have like get min. For get min, things get a bit more complicated though. So we'll have like get min, we'll be passing self. It's not mutating. We know that it should return an I32. So yeah, the whole trouble with this data structure would be this stuff, the get min, because we'll need to think of a way on how we can keep the, let's say, the get min part to return it in a constant time. All of these actions are constant time, so push will be constant time, pop constant time, last as well constant time. So we should maintain our constant time calls for this data structure. Okay, so yeah, let's define our test case for this. So we'll have like test min stack get min. Okay, so let's define this test. Now as well, we'll need to probably I'll add a couple of numbers. So let's add min stack let me push, I don't know, -3, and I'll be okay, not expected, so this would be result. Yeah, let's rewrite this, and this would be like expected. So we'll do like let result would be min stack dot get min. So we expect this to be -3. So assert equal result to be equal -3. So this it's our test for get min. So now we need to come up with the algorithm which will handle this this thing of our. And for that, we'll need to probably brainstorm a bit on our whiteboard. So yeah, let's move to the whiteboard part and check there. What can we do here? So let's imagine we have like a stack, because we have our data, which is a stack. So we have our stack here. So we introduced first like 1, and then we introduced -3, and then we will introduce like 2, and we'll have another one like I don't know, let's put it -2 again, -2. So this would be the top of the stack. I guess, yeah, we have one more place, and let's put a -5. So this would be like our stack. If we call min or get min at this stage, if we have this stack and we call get min, we should receive like -5. So once we got -5 and we do a pop, then we'll not have this item anymore. So the top of the stack would be this item, and then we'll have like -2, 2, and -3 and 1 inside the stack. So this will be the remaining stack. So if we call again, in this case get min, the answer should not be like -2, like top of the stack, but should be like -3 in this case. So so yeah, that's a little bit interesting approach on how can we do it. And a hint, because I was thinking last time, how can we do this? A hint for how to solve, or the key to this problem, because yeah, problems in LeetCode are pretty complex most of the time, but once you know the key, they became like pretty easy. So mid-level problems, a thing which you can do and try to understand, it's this part, which I to be honest, I didn't get it at first. So I dug a bit on discussions, watched a couple of videos, and finally understood what's the idea here. So we need to consider that each node in the stacks have a minimum value. So yeah, it's a bit abstract, though what the author of that comment wants to tell, it's like when we build our stack, we kind of should have 2 stacks. So one would be like the data stack, and the other one would be like a min stack, where we'll be storing every, let's say, mean value for each level. So we'll be mirroring this this part. So imagine we introduce 1 in our stack, then the min stack will mirror at this level what would be the minimum value. So it will be like 1. So if you introduce here a new value like -2, we'll have another level at this in the min stack, where like the min stack data. which will be -2 again. So imagine now we'll have like another value here, which will be like 3. In this case, we'll have for this level another, we'll be looking, let's say, if 3 in this case it's less than -2, and it's not, and we'll be posting as well -2 here, the same level. So if we go further with like -4, then automatically -4 will become bigger. And if you have like here a 5, we still will have -4. So this is pretty awesome. Yeah, we will need like for this, I think the sole inconvenience would be like we'll need like O of n space, so we'll need linear space. So because we'll need to have like not only one stack but 2 stacks, but it works very, very well. Because imagine we use pop now. So what we'll be doing if we do pop, we'll get rid of this level. We'll have like 5, but we'll do pop on both of our stacks at the same time. So we'll need to duplicate our action. So we'll be popping this one. So at the moment where we want to get the min, so if we want to get min of at this level of -4, we'll be looking at the top of the min stack, which will be -4. So we'll be getting -4 in this case. If we are popping -4 out of this, then next time which we want to check the min stack, it will be this one, -2 already. So this is a pretty cool concept. I didn't knew about this trick. But I guess it's a good pattern to know when you need to have like let's say a data structure which needs to maintain a minimum or a maximum. So for stack kind of operation, this strategy of duplicating it, so for max would be similar, but we'll be inserting here not min but max. So this will be like pretty cool things. So yeah, overall the idea that's the idea. Yeah, let's get back to coding it. So yeah, we define like data, and we'll have another one which we can call it like min stack, which will be a back of 532. But probably like data and mean data maybe. Yeah, maybe let's call it data and min data. So for the sake of writing it down, yeah, we may write a comment here. Yeah, as a good practice, when you define structure, it's a good idea to write a simple explanation. What's this used for? Because for min data, we will store the min value for each stack level from data. Okay, so it's a small comment here for us to understand what's going on. Yeah, here we'll need to duplicate the min data part. So yeah, important moment here, because we are inserting our data inside. So at this moment we have like 2 options. So first we'll need to check if it's empty. So if we have like self.data is empty, in this case we will not bother much. So we'll do like self.data push vol, and we'll be pushing as well self.mean data. We'll be pushing the value because we don't have anything in the stack. Else it's a bit more complicated, because what we'll need to do, we'll need to check what's on the top of the stack of min stack. And to do that, we'll do like if let sum. Yeah, we know that there is some, but let's use top. and this would be like self mean data dot lost. So we'll need to check the following. If a top, in this case, it's yeah, let me think. Not like this. So yeah, we'll be getting the top, and we'll be inserting at the level of I guess here we'll be doing in either case, what we'll be doing is we'll be inserting self.data.push. So yeah, we'll push value. We'll push the value in either case. Though here it's important what we'll be inserting at the same level in min data. So we'll be inserting, we have the top, so we'll do like self.min.data, and we'll be pushing the max, or yeah, the min value between the val and top. So we'll be pushing this. Okay, so we have the push logic. Here, the thing, it's, yeah, so I guess the idea is if we move at this part, we have like the normal stack, where we have like data stack, and we have like the min data stack. So if, for example, data it's empty, nothing is there, we just push in both, because we don't have anything. But here at this level, if we want to insert the second too, then we'll need to look what's on the top of the stack, and at this moment on the top of the stack is 1. We'll need to compare with the current element 2. So if let's say 2 it's smaller than 1, but it's not, then we'll be inserting 2, but in this case we'll still need to insert 1. So that's the logic. That's the logic which we implemented. So how did we implement? We push data, and we check the top of the min data stack, and we push the minimum between those two. So that would be the logic for push. Now what we'll need to do for pop. For pop, actually there is not anything specific. Here what we'll need to do is we'll need to pop from both in data pop. So we'll need to pop from both, because we once we pop from one, we'll need to nullify both levels. So this is what we are doing. So if we pop again, then this will be done. I personally don't like it a bit, because we don't have a shield for the case when we'll be popping, let's say, on an empty stack. So if we call pop on an empty stack, this will panic. But unfortunately, the interface, yeah, I guess we can shield from that. So what we can do, we can do like self.data is empty, so we can write this if statement. If it's not empty, then we pop it. If it's empty, then we don't need to do anything pretty much. So we'll be shielding from this part. So for top, that would be top will give us the last element, and it will not mutate anything. And get min for us, it will be similar thing, though it will do like min data. So I think that should be it. Yeah, we can define a couple more scenarios and check. Here, does it work or not? Yeah, this works. Maybe I can create a more complicated one and check if this will work or not. Cargo tests, so all tests are fine. Yeah, this seems to be done kind of. yeah, let me, I don't know, create a couple more scenarios. Maybe let's wrap it up with a test case from LeetCode. Test means stack works fine. Okay, so this would be like just okay. So let me do a test, and we'll be copying, let's say, the scenario from here. And yeah, so let me check. Yeah, it will be a bit problematic to test everything, but I guess that would be my okay, so it's a bit weird. Yeah, we don't have the structure. Yeah, this is a not a Rust way to do things, so we'll do like min stack. So we have a push, 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 and here we have like a get min. And we do like a result at this stage, and we can do an assert. Result should be like -3. So we do this, we do like top, a pop, then we do top. Yeah, probably I can do it this assertion in one place. So we do like assert equal top. This should be equal to 0. Yeah, so this is directed, so I'll need to mark it as expected. And for the last one, we'll do similar. So assert equal. I'll have like get min. Yeah, this is a bit weird because I don't understand. Oh, okay, so we do a pop here. So yeah, that's clear now. Yeah. So it doesn't work as this needs to be mutable. Okay, so now it's good. Now it's really, really good. Okay, so we do this, we run our tests, it's working just fine. We can run all tests, working just fine. Yeah. Cargo tests, everything is good. We run cargo clippy to see what suggestion we may, how can we improve our code. Yeah, so this may be a good example. Yeah, it suggests instead of new. So yeah, actually it suggests to have a default for our min stack. You should consider adding a default implementation for min stack. I mean, yeah, it's not asked for us, new without default. But I don't think it will be like a huge problem. So let's implement it, implement default for min stack. And we'll have like the default. Which will be like self.new. Yeah, that should do the trick. Let's see if Clippy is happy. Yeah, Clippy it's happy. Yeah, next stage would be I would copy this in VS Code and run it there and see if this works or not. I really hope it do. So yeah, let me run first to see if this compiles. Yeah, it does, and now let's submit. Indeed, it does work. Maybe it's not the fastest, so let's see other solutions. Here, similar. Yeah, this is how you get the last part, so maybe a bit complicated it. I don't know. I mean, it's exactly the same concept, maybe written a bit differently. So yeah, we nailed this one as well. I guess time to move on. So we managed to do it in a test-driven development style. Now it's a good time to kind of commit it. Git status, git add, git commit. Solved, min stack, 155 problem. And let's push it. So we nailed this one. Time, I guess, to close this window. And here we can close this one and we can mark min stack as done. So one step closer to finish, let's say, this challenge. So yeah, next one, I think I've solved it already. I solved it a long time ago because it was one of the problems of the day. But I'll look through the code and try to explain what I'm doing. And maybe we can improve it a bit even. But yeah, first let's see what's the problem about. So we need to evaluate reverse Polish notation. So we're given an array of strings called tokens that represents an arithmetic expression in a reverse Polish notation. Probably it will be easier to look at some examples. So we have like 2, 1, and plus, and then we have 3 and multiply sign. So the idea behind it's the following. So we have like a first operand, second operand, and we have like the sign. Then the similar thing, once we execute this, the parentheses will have like a first operand and second operand, and the sign will be multiplication. So yeah, that would be the whole idea. And what I'm doing, I'm getting the tokens and I'm checking that there is a sign. So I have like a sign vector. So yeah, probably I will not need this. And yeah, let me see. Because it's not like it's a fixed size vector, so probably it works like that. But I'm checking if the current token it's a sign. If it's not a sign, then I'm parsing the values. Because yeah, I'll need to parse the values and I'll need to push them into a stack. So yeah, probably it will be better a bit to draw it on the whiteboard. So we have the following, let's say, tokens. So we have first, which will be a string like 2, and we have another string like 3, and we have an operand like plus. So that would be the tokens in Polish notation. So in this case, what we are doing, I'm checking if these are numbers. I'll be parsing those numbers and insert them into a stack. So I'll be doing things like this. I see 2, I put it into a stack. I see 3, I'll put it again on top of the stack. I've got like plus. This means I should have in my stack 2 operators, 2 operands, like first and the second. And what I'll be doing, I'll getting them in reverse order, because 2 and 3 would be like 2 plus 3. So I need to make sure that I have the right order. So then I'll do the following, like second. I'll be popping from stack, will be stack pop pop. And then first will be stack pop again. Yeah, probably I'll need to use a bit more space. So this will be like second operator, and this would be like first operator. So I do two pops. We can check it in the code. So this will be like right. Well, yeah, I guess will be like right and left. That would be, I guess, a more a clearer way to look at this. What I don't necessarily like it's this unwraps, because if we don't have anything in the stack, so let's say we have some wrong structure, then we'll have troubles. So yeah, it's a bad practice to call unwraps in such a manner. Another way to do it would be like a nested, I don't know, if let sum. So let me probably write it here as an example. But the constraint which allowed me to do this, it's this one. The input represents a valid arithmetic expression in reverse Polish notation. So I'm expecting it to be valid, so I shouldn't have troubles with this part. So yeah, I have like the right operand and the left operand. And next I'll be doing, so yeah, here the stack is full. So once we got to an operator like this, like plus, minus, multiplication, or division, I'll do a match. So if it's a plus, I do left plus right. If it's a minus, I do left minus right. So I'm executing this function. And then it's important that we push into the stack the result. So always in the stack would be the final result of our Polish notation or Polish notation expression. So yeah, if we look at this example here, we'll have like popping these two, doing the operation. So operation would be like right would be like 2 plus 3. And we'll be popping this two from this stack, and the new stack will contain the result, which will be like 5. So we can get the stack of 0 or the top of the stack. I guess probably calling top would be a bit more or a bit better. So we can call like top of the stack, and will give us the end result of our expression. Yeah, I guess that's pretty much it. Concerning this Polish notation. So I'll be marking this one as done as well. Yeah, another step closer to finishing the stack kind of problems. So we have a cool one, next one. It's generate parentheses. And this one is a pretty cool one because it has elements of dynamic programming and backtracking, which is pretty cool. So we'll need to generate stuff. Yeah, so the idea here, we are given an n pairs of parentheses. So we receive an n number. We need to write a function that generates all combination of well-formed parentheses. So we have like n equal to 3. So here we have an option like this. This is a form. Another form would be like this one. We have this possibility. We have this possibility, which is pretty much this one, but a bit reversed. And the last one would be like 3 parentheses in a row. So so far this I would consider like one of the most complicated ones, though this has like acceptance rate of 74.4, which seems like it should have a easy solution. Now I'm not sure I would manage to solve it so fast. Okay, I guess that would be the plan. First stage, I would start like working on adding the code for this, setting up my VS Code structure. So we'll do, but let me first try to find uh, how it's called, because I worked on this one, I think, generate parenthesis. Yeah, let me see what we have with generate. Yeah, not here for sure, so I need to get out. So I did work on this one, and I feel like I have something there. Yeah, let's check. What do I get? Yeah, nothing. So I started, but I didn't manage uh, to advance much. But at least I have everything set up, which is a good thing. Probably I've got this problem in some of the weeks, but I couldn't manage to solve it somehow. And yeah, I guess now is the time to brainstorm a bit on what can we do about it. So let's see, do we have not solution but editorial? No, it's blocked. Yeah, that would have been funny. So we'll see. Do we manage to do ourselves or not? We'll try our best to do it with the knowledge that we have. One critique which I would add about LeetCode, it's some of the problems are, let's say, extremely opinionated, in the form of either you know the solution, you know the key, or you don't. Like, if you know the key, the problem it's extremely easy. But if you're in, let's say, average engineer, which does like usual stuff at work, because you rarely need to play with these kind of things, then for you it will be nightmare to come up during an interview with a solution like this. So I personally not a big fan of this kind of checks, to see if you're a good engineer or not. Yeah, I understand that I need to train to pass interviews. I need to train this kind of problems to pass the interviews, but I'll be honest. If I'm an interviewer and I give this problem to someone, and if it solve it, he knows how to solve it right away and he does it fast, I wouldn't learn anything about his skills, because this will tell me that he spent a lot of time grinding problems on LeetCode, but not necessarily learning, understanding higher concepts and so on. So yeah, it's a bit problematic, the situation right now. Either you grind problems on LeetCode and pass interviews, or you don't. But rarely see correlation with how good you are at LeetCode and how good you are as a programmer overall. Yeah, algorithmics it's important, but it's not the most important thing for a programmer. So this needs to be clear. But yeah, there is overemphasis on, let's say, algorithmics, and not even algorithmics, because if it's like fundamental stuff which an engineer should know, I may agree that this is important. But sometimes the problems, they really have a very narrow specific key, which in a lifetime of programming, because I have like I have like 12 years now of experience at my work. I would never encounter a real problem which kind of I need to solve this problem, this specific problem. So I would not have any experience or any idea on how to do it. So yeah, this is not necessarily a thing which I like about this LeetCode culture. But yeah, if you want to get to Google or Meta or some FANG companies, there unfortunately are not a lot of other options. So you kind of need to grind, need to go problem by problem, understand them, train again and again, memorize solutions, understand concepts, and still you may get to some hard problems on LeetCode. Either you know the solution or you don't. You know the key to it or you don't. So yeah, tricky. Okay, so we are here. We have a scenario defined, and now let's think, how can we tackle this problem? For now, I don't know exactly how I would tackle it, but I'm still an experienced engineer, so I need to come up with a solution. So imagine I need to generate some stuff. I would go with the brainstorming session. So let's dive in here. So let's assume we receive some number like 1. For 1, there is only one option. What we'll need to return, it's a vector of this parenthesis. When it's 2, already we'll have like 2 other options. For 2, we'll have two options. So we'll have this combination, and we'll have the second combination, which will be an inside stuff. So if you go for free, things are getting even more complicated because they start exponentially to grow. Or I guess not exponentially, but there is a exponent law, so we'll need to define it and see it. But they grow pretty fast. So for free, we may have this option, like this. I guess we have the solution here for free. It's how many there are, like 5. So five different options. So if we start going with a law of some kind, let's say we have, because it feels like this needs to be a recursive approach. So let's imagine we have like first, in either case, we will need to start with the parenthesis. So if the parenthesis it's only 1, I guess if n is only 1, then we have only one option to close it. So that would be a final part. But if n it will be bigger, so let's assume we have n equal to 3. Then out of this, we may branch to 2 other options. So either we go open another one, or we may close it. So if we open another one, at this stage, we will have like n being equal to 2. And here n as well will be equal to 2. Or no, actually, we'll need to store the remaining stuff. So we'll have like n equal to 1, because we have one more parenthesis remaining. And here, so yeah, probably let's go like this. So at first we have like n equal to 3. Then we have 1. So we removed one parenthesis. So we have, at this stage, we have n remaining equal to 2. So if we go at the next stage, we may open it. So we'll have like n equal to 2. No, to 1. And if you go on the right side, we'll have like, we close it, because we have this option to close, and n will be equal to 2 again. So we move on. For this one, we either open another one, and for this n will be equal 0, and we'll need to kind of close the next iteration, or we can close this one, And for this, we'll have like n as well, remaining one. So still we need to put somewhere another parenthesis. So we start going recursively. For specifically this case, we cannot open anymore. So here, out of this, single solution would be to close everything. So that would be like a final solution. But this one starts expanding, because for this one we may have two other options. So yeah, probably I'll go here, or yeah, let's go in depth concerning this one. So here we may have two possibilities. Either first possibility, we I guess close existing one, and for this we'll have n equals still 1, because we need to open one more parenthesis. Or we may have this option to open another one. So we'll be opening another one, and for this we'll have like n equals 0. We cannot open any more parentheses, so we'll be forced kind of to close the remaining on next stage. So for here we'll have another possibility, but I guess it's only one possibility in this case. It will be like this. So we open, we close, and then we open. So this will be like n0. We cannot close because they are already, it's only option to open. So I guess here the next one would be the final, which would be this one. Open, open, close, open, and we close it, and we have another final solution. But probably what I don't like, it's closing. I do not see the algorithm here always. So yeah, we will see about this in a minute. So for example, here, what's our options? We here next next option would be to just close it, and this would be this solution. It will be open, open, close, open, close, and close, and we will have this, and this would be like another final solution. And if we go, what else remaining here? So here, what's our option? If it's closed, then we can only open. So it will be like n remaining 1. And remaining 1. Here, what else can we do? It will be like we can close, and then the remaining 1, and we can open another one. So this will be like this, and we open another one, and here n equals 0. So both of them are 0. No, here it's n equal to 1. So next iteration, here we can open 1 and close, and here we can close both. So here we've got all of our 6 solutions as defined. So yeah, as we can see here, it's a kind of a recursive approach. But it's intuitively I understand how this stuff works, but I'll need to think on how we can write the code for this, because that's a bit more complicated. Yeah, so yeah, we have like 1, so this would be a solution. The second one, third one, fourth, and fifth. So 5 solution as provided in the description. So this would be like a generative approach where we define our solution. And imagine this goes even funnier for higher numbers like n equal to 4. So probably here we will need like some memoization technique to help us with the results. Because let's say, yeah, I'm not sure if I did though. I did the right thing with open closing stuff. Here, this part I didn't get it correctly. So yeah, let's go again. So let's imagine we have like n equal to 2. So we have like two parentheses. So first iteration, we start by opening. So we have this in our, let's say, stack. If we opened 1, then automatically we should reduce n by 1. So we will decrement n. Next stage, we will get this vector and we will do the following. We'll have a copy of this. So for each item in the stack, in this case it will be 1, we'll need to do a fork, kind of a fork, yeah. So first thing we'll do, we'll have one option to close the bracket. So we'll do like this. So that would be one option, but the second is to open another bracket. So this would be, but in this case, if we open one bracket, then n would be 1, because still we need to open 1. Yeah, so we're going the same direction though. Yeah, so I guess the trick here is to go depth first search. By depth first, it would be like from here we go yeah, I don't know how to backtrack this. That's the trick. So we will need to backtrack from this level. So yeah, backtracking from this level. That's actually interesting. Yeah, I'm thinking how to properly do this. Yeah, let's start. Let's start, and we'll see. We'll see how should we go. Okay, so we do have this, and we'll need to return our string. We know that this it's like a recursive function. So yeah, we know it's a recursive function. So probably simplest way to go would be to have base case scenario. So one simple case would be like n equals 0. So what happens when n is 0? When n is 0, probably we'll need to have something in our stack. So yeah, we'll need to have a stack, and if we have n equals 0, If we do have n equals 0, what possibilities we do have here? So do we return the stack? Or the other possibility is if we have only open things in the stack, then if n is equal 0, we'll need to check how many are opened, and we'll need to close all of them. How many parentheses are opened. So let's assume we put into the stack this and this. So if we have this in our stack, then the final string would be how many we need to close. So the final string would be this one for n equals 0. So we'll be counting how many items in the stack. So let's assume len equal to 2 here. Then we have a string which will be like 2 multiplied by 2, because we need to close all parentheses, and in this specific case the end result would be this one. Yeah, actually this one. So for n0, an empty stack, so let's do a couple of simulate a couple of scenarios. So if we have empty stack, then end result, I guess it will be empty string. If we have something in the stack, let's say one opened bracket, then the end result would be a closing of this, so this would be the final string. So if we have multiple, like x, then here we'll have our final string would be this, 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 and we'll need to close everything. So the law here, it's we'll have some sort of DFS function where we'll be providing an n number, and we'll be providing a mutable stack. Where we'll be calling it recursively. But my trick is, how can we join all the answers together? And also, what should we do? Because sometimes in our stack we don't have only open brackets. So here we have the trick. We need to think what to do with non-open brackets. But maybe do we need to care about that? Maybe we don't need to care at all. So DFS stands for depth first search. So usually it's first search. So this is like a binary, not a binary, but a graph algorithm to check in depth. So for this specific case, actually it works just fine when we only open brackets. But I need to kind of store the results for the already closed ones and then join the end results. Okay, I guess let's go again with the 3 n equal to 3 and try to simulate it again. Maybe we'll come up with like some decent algorithm. So yeah, at first let's imagine that we have one. Maybe we can go with a tabular method or something. Not necessarily with depth first search, but to to grow it backwards. So let's assume we we put into the stack 1 bracket. What does it mean? Does it mean that n will be equal to 2 in this case? But this will fork into two possibilities. Like we may close it right away, or we can open another one. So if we close it right away, how do we store that? So this would still be like, yeah, maybe I can do it like this. Not necessarily only one, but we'll do this doesn't work. This doesn't work though. I think we should make this one smarter a bit. I guess the algorithm here for n equals 0 would be something like this though. So if we do have anything opened or closed, so we need to match. So if n is equal 0 and we have this state of the stack, we'll need to match like open brackets and close brackets, because we cannot open anymore, but we need to for open and close to be the same. So in this case they are both 1. So imagine we have like such scenario, we have 2 opens and 1 closed. This is totally possible, but n is equal 0, so this will be like 2, but this will be like 1. This is a no-go, and we will need to make sure that the amount of close are equal to the one opened. But actually that's exactly kind of the similar thing here. So probably at this stage we'll do something like we'll do a count of how many are opened and how many are closed, and we will fill the remainder. So we'll do like 2 minus 1, and this means I will need to add 1 more or x more. Maybe it's already closed. And this would be good enough for us to make sure that n is 0 and it's good. So now when we do this DFS kind of algorithm, I may have like different kind of stacks or vectors maybe, where at first I do start with this. So if n is greater than 1, so let's start again with n equal to 3. So I'll have right away my final result. Let's say it will be something like I'll have a vector, I'll have a tuple, I'll have my stack, and the stack would be like a starting 1, and we'll have another option like 1 closed. And we have the remainder of 2, which would be like how many remaining are there? Okay, but actually this should be in different stacks, so probably that would be better to have different stacks, or a vector of stacks. Let's put it this way better. And we will have like this would be closed, and we have like 2 more. And if you go deeper, the next stage, we will kind of go towards each one of those. So this one will be another tuple. We'll start our main thing here, but here we will open each one of those. So here we'll do this. It will be 1. Then we'll have the second one, which would be closed. No, this will be 1 opened. And this would be, the second one would be this kind of, and we open another one. So that would be this step. And will be n equal 1 here. So now if we move on to the next step, we'll have a similar thing here. So we'll open all of them. That would be 1. This one would be, yeah, here actually this one is closed, and yeah, we need to add one more. So that's not correct. Here we'll have this option, and we'll have just opening. Oh, hello. Yeah, the problem is called generate parentheses. So what I'm trying to do right now, it's following the LeetCode data.io roadmap to learn data structures and algorithms. So here I have like a list of problems to solve from LeetCode, and now I am on this one, generate parentheses. So this one, it's backtracking. This one is a backtracking kind of dynamic programming problem, which I do not have a lot of experience working with, and I've tried to improve my skills in this regard. So yeah, at this stage we have this, and we have this, but we will be opening another one. And now we will have our reminder being 1. So this is somewhat the way how our solution will grow. So we will have here the full solution. So we will get the third approach. So this will be first one, which will be open, open, open. Then we'll do this, which will be open, open, and we do opening here. For this, yeah, actually this is not possible because I'll need it to do, wait a second, this something is not right. This is not 1 remaining, this is 0 remaining. Yeah, I got confused myself. Oh my god. Yeah, this is getting tricky. This is getting tricky. Oh, YouTube a bit laggy. Shows us the connection being good, so I don't know exactly what can I tell. Shows like connection is good, excellent connection. Maybe it's possible. Yeah, weird. I'm not sure. How can I help you? Maybe it's your internet connection. Does anyone else experience this? But yeah, actually, I cannot ask anyone else. Yeah, let me check from my client side if the connection seems good. Yeah, with chat, it's a bit weird because sometimes it's not shown, but I do not see any like troubles for now. Yeah, I'm not sure. How can I help you? Yeah, unfortunate. Sorry, bro. Yeah, by the way, still, thank you for coming in, asking questions. Uh, really, really like it. So yeah, let's try to write something here. Yeah, I guess let's start first with the first scenario, simplest possible scenario, and come up with n1, and we'll have like this. Oh, right now I think it's stable. Okay, that's good. I don't know, technology. It's not reliable. Yeah, okay. Yeah, you mentioned it right. Continue to try to solve it. Continue to try to solve it. Okay, so yeah, what else can we do? Maybe I can do some sort of for loop. And where yeah, still I need my stack, where I guess stack of stacks or results maybe. Uh, I'm not sure if I'll need this I anymore. Just need to iterate it enough times. So yeah, let's write the results here. I'm thinking maybe I can maybe I can loop it an amount of times. Oh, yeah, I do work with JavaScript as well, and I used to work with PHP. At work, I do Node.js and TypeScript. I used to work in with Symfony in PHP, a bit with Laravel, but mainly with Symfony. So, but a long time ago. Latest like 5 to 6 years ago, yes, I switched to Node.js, so writing TypeScript mainly Node.js. But Rust, it's a very, very good language to learn if you come up from only scripting languages. So I suggest you to try it at least to learn a bit about like the memory management, how it's done in Rust, lifetimes, and so on. How to describe language in terms of learning? What language you better for? I'm not sure I understood the question. Uh, I recommend Rust. Yeah, at my current job, there is not a lot of options where I can really use Rust because I still consider it pretty new. But if there are like any performance, yeah, it's a very like very specific scenarios when Rust would be a good choice. And most of the time, for a simple I/O operation like API creation, I would always go with Node.js. It's way faster. I mean, not faster in the sense of I mean human productivity faster. I write in Node.js way faster than in Rust. So it's pretty painful to write like a complex application in Rust. Let's be honest, uh, that's not a fast thing to do. But if you need like a raw performance, and this is specifically for very specific scenarios where we do have like synchronous operations to be done, or not a lot of I/O things involved, Rust can give you raw power and you can improve the application by a ton. And actually, what you can do, you can write native like libraries using NAPI or NAPI. So you write like Rust code and execute it in Node.js. And we kind of tried this with some success. Still not perfect, has some troubles here and there, but you can like extend Node.js to use yeah, Node is extremely strong. Because most of the time when we do I/O operation, this means creation of the APIs, connecting to database, request response stuff. It's very very powerful and fast enough. That's the thing. Yeah, it doesn't compare with like Hello World written in Rust. So any server written in Node will be slower than a Hello World static server for Rust. Though I did some checks comparing like I/O we're close to production things like you have a database, you do a call in of some APIs in Node.js and compare the Axum from Rust, and the performance is not as noticeable as the benchmarks of static of Hello World are given. So for example, a Hello World in Node.js, the fastest framework, which would be like Fastify, would give you like 35 to 40,000 requests per second. In Rust, a similar computer can give you raw power of 800 to 700 thousands of requests, so 10x. But if you do a operation like connecting to a database, doing a request, sending the response back, uh, it's not at all like this. It's barely like a 10 to 50% better. But the amount of pain which you'll need to deal with writing Rust is incomparable. So I'll be 10 times faster in Node writing the same thing, and I'll get only 10% more performance if I write it in Rust. And let's be honest, the cost of engineering, it's by far more, it's bigger than CPU. Yeah, this is another thing. Ecosystem of Node is extremely big. It has its drawbacks, but I totally agree. I mean, amounts of components, frameworks, like very mature frameworks, like one of the favorites of mine, like Next.js, where we have like TypeScript with proper dependency injection. Uh, like Jest for testing. So yeah, it's if you start an API, highly suggest to write it in Node. the productivity versus performance, it's by far the biggest from the languages which I worked with. Maybe comparable would be like Go, but people who work in Go, they tell like it's also a little bit problematic and not as fast as writing TypeScript and JavaScript. Yeah, I do know about this problem. I'll be honest. I'm a bit exhausted because I had like a pretty tough week. So very likely I'll just continue with this one during my next stream. Also, I'll need my head to be cleared to come up with a decent solution. So yeah, overall I feel like I'm digging in the right direction, but there is the key which I miss, and my puzzle is not full. Okay, I think I'll be closing for today. I managed to solve a couple of problems during this stream, but this one is a bit beyond me. So I'll be continuing this one during next stream. So probably during weekend, Sunday. Hopefully I'll have a stream. So yeah. Al-Wadil Wabel. Yeah, thank you for joining in. Thank you for writing comments and other ideas. By the way, where are you from? Yeah. Oh, hello, guys. Yeah, people join to start commenting, and I just want to close the stream. So this is a bit rude, to be honest. Kiesa. I'm not sure if I. Yeah. Search for my name. Al-Wadil Wabel. Yeah, let me search. Al-Wadil. I'm not. Yeah, Al-Wadil home. Learn more about me. Okay, cool. Work as a project that helped me many clients achieve goals. I have been working in the field of more than 15 years. I have experience programming websites from scratch and achieving your vision to reach a bright future. Really, really cool. Yeah, nice. Hire me. Yeah, let's see. Oh, nice CV. What can I tell? Marketing. So what's the country though? King Khalid University. What is that? Saudi Arabia or something? Yeah. Okay. Smart accounting training projects. Yeah, we can connect on Twitter. I also do have an account. Okay, yeah, I think I found it. Yeah, cool. But it doesn't tell what's the country though. English. Is it Saudi Arabia? I think it's Emirates. Yeah, cool. Yeah, by the way, Panagliolis Zarikos. Hello. Yeah, I assume you are from Greece? Yeah, Saudi Arabia. Nice. That's cool. Yeah, so one of the goals with this stream of mine is to create like connections and friends where we can communicate, try uh, to connect to different people. So that's really, really cool. Uh, I am from Moldova Republic of. Yeah, I also do have a website, so you can find me here. alexolar.com. So Alex Olaru. So that would be my name. Where I do post like different articles on Rust and many other topics, Node.js, some data structures, some live coding sessions, some team leading articles. I used to be a team lead. I'm not sure if I have a CV posted here. Maybe, maybe not. I don't recall though. I think I plan to do something on this regard, but yeah. I used to have like Node.js certifications, but both of them are expired, and I don't want uh, to do them again because they are pretty much useless, to be honest. So just wasted money. I had them and I didn't receive any job offer, both on LinkedIn or any other. And I posted them on LinkedIn that I am certified, blah 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 and stuff, but that's not really a thing. Cool, cool, cool. So Stack Overflow. Yeah, Nick. This doesn't show though the amount of only 68 reputation. Okay, so I am bigger on Stack Overflow. I do have like 7,000 close. Yeah, yeah. Thank you. Yeah, pretty good connections. Yeah. Okay then. I think I'm done for the day. I'll be streaming. I'll try to stream more consistently, but usually on Fridays I do stream, and I do on Saturdays. And hopefully I'll continue with this LeetCode.io. Um, I finished during the last streams like 2 pointers, all the problems. I've solved them. Today I've solved like min stack and this reverse Polish notation, and now getting stuck at the generate parentheses. Yeah, thank you. Yeah, bye bye, guys. Yeah, closing this one.